Introduction. Originally, this type of problem can be solved using only algebraic formulas, but in this lesson, we will also draw graphs so that we can practice absolute value, symmetry, limits, and continuity together. We are working with a piecewise function defined on the interval from -1 to +1. The function f of x is defined as follows. For x between -1 and 0, f of x equals -1 half times x. At x equals 0, f of 0 equals 1 half. For x between 0 and 1, f of x equals x minus 1. Problem 1. Graph y equals the absolute value of f of x. To sketch y equals absolute value of f of x, we take the original graph of f, and we reflect any part of the graph that lies below the x-axis upward so that it becomes positive. Step by step. On the interval from -1 to 0, f of x equals -1 half times x. This is already non-negative, so the graph stays the same. At x equals 0, f of 0 equals 1 half, so the absolute value is still 1 half. On the interval from 0 to 1, f of x equals x minus 1, which is less than or equal to 0. The absolute value makes it positive, so the rule becomes 1 minus x. So the final absolute value function is, for x between -1 and 0, y equals -1 half times x. At x equals 0, y equals 1 half. For x between 0 and 1, y equals 1 minus x. Problem 2. Let g of x equal f of x plus the absolute value of f of x. We want the limit of g as x approaches 0 and the value at 0. Case 1, when x is less than 0, f of x equals -1 half times x, which is non-negative, so the absolute value is the same. Adding them gives g of x equals -x. The limit from the left as x approaches 0 is 0. Case 2, when x is greater than 0, f of x equals x minus 1, which is non-positive. Its absolute value is 1 minus x. Adding them gives 0. The limit from the right is 0. Therefore, the two-sided limit is 0. At x equals 0, f of 0 equals 1 half, and the absolute value is also 1 half. Adding them gives 1. Answer is colon. The limit of g of x as x approaches 0 is 0. G of 0 equals 1. Problem 3. Graph I equals f of -x. This is the horizontal reflection of f across the y-axis. Work it out piece by piece. From the left branch of the original, f of x equals -1 half times x. Replace x with -x. That gives positive 1 half times x, valid for x between 0 and 1. At x equals 0, f of -0 equals f of 0, which is 1 half. From the right branch of the original, f of x equals x minus 1. Replace x with -x. That gives -x minus 1, valid for x between -1 and 0. So the new piecewise function is, for x between -1 and 0, y equals -x minus 1. At x equals 0, y equals 1 half. For x between 0 and 1, y equals 1 half times x. Problem 4. Let h of x equal f of x plus f of -x. We want the limit of h as x approaches 0 and the value at 0. Case 1. When x is less than 0, f of x equals -1 half times x. F of -x equals -x minus 1. Adding gives negative 3/2 times x minus 1. As x approaches 0 from the left, the limit is negative 1. Case 2. When x is greater than 0, f of x equals x minus 1. F of negative x equals 1 half times x. Adding gives 3/2 times x minus 1. As x approaches 0 from the right, the limit is also negative 1. At x equals 0, f of 0 is 1 half, and f of negative 0 is also 1 half. Adding gives 1. Answer is limit as x approaches 0, negative 1, h of 0, 1. That completes all 4 problems. The absolute value graph is reflected where needed. G of x has a limit of 0, but a value of 1 at 0. F of negative x is the horizontal reflection. H of x has a limit of negative 1, but a value of 1 at 0. Lastly, one important thing not to be confused about. In the original function f of x, if we look at the right-hand limit as x approaches 0 from the positive side, we are considering values of x that are just greater than 0. But in f of negative x, when x is just greater than 0, negative x is actually just less than 0. So, the right-hand limit of f of x at 0 corresponds to the left-hand limit of f of negative x at 0. If we raise the level of the problem one step higher, it could become a question about checking the continuity of the absolute value of h of x, or the product g of x times the absolute value of h of x. Think about it.